So let me say hello to everyone. And since we have people from every continent, it's a good morning to those of us here in the Americas. I'm in Miami, and good evening to Asia and Australia. And good afternoon to all of you who are in Europe, Middle East, and Africa. And welcome to this very special Wellness Masterclass with Dr. David Brenner, Fred Maxik, and Dr. Michael Roizen, The Power of Light, Fighting COVID-19 and Future Pandemics with Far UV. And any one of these people could be their own masterclass, but we are very fortunate today to have all three. And so I'm very, very excited about what we're going to be learning. And I will introduce myself for those of you who don't know me. My name is Susie Ellis. I'm with the Global Wellness Summit. And in a minute, I'm going to turn it over to Nancy Davis. She is our Chief Creative Officer and Executive Director and the founder of this Wellness Masterclass series. So she's going to more formally introduce our three guests. I just like to say something a little personal, and I'll start with you, Michael Roizen, because I have visited you in Cleveland, and a couple of things about you. One is I love your title, and I don't know how long you've had it as the Chief Wellness Officer. Isn't that the right title? Yes, Chief Wellness Officer. But Wellness Officer, that was a big deal for all of us in the wellness industry that someone at Cleveland Clinic had that title. How long have you had that?
So I'm now emeritus, but we started the Wellness Institute in late 2007. So I was the Chief Wellness Officer till last year, and now I'm emeritus. But I still see patients and do this and enjoy doing it.
Well, in 2007, that was really radical to have a title with wellness in it, because I know we weren't really using the term much. So, but you've really blazed the trail. And I also will just say about Michael, when I visited you, you were, somebody grabbed you and said, okay, we have to do some TV thing. And you just sat down in the chair. And I mean, I've never seen anyone so comfortable in front of a camera. So anyway, no wonder you're on TV a lot. So I'm glad you're here, Michael. And Fred, we've seen each other a few times. We've had dinner together. And all I can say is that I've never been more enchanted by someone sitting next to me talking about lighting science. So I know you're going to find him extremely interesting, fascinating. And I just came away realizing this guy is the top of the game. I mean, there's nobody that knows more about this topic than you, Fred. And David, I haven't met you yet, but I see from your bio that you are an expert in radiation for the layperson, which means that's me. And I know, being part of this team, you have a stellar background, and I can't imagine what the three of you have accomplished together. So with that, I'm going to send it over to Nancy for more formal introductions, but I'm really grateful to the three of you for being here for us with this Wellness Masterclass today. Thank you.
Thank you, Susie.
We feel lucky being here, Susie, so thank you.
Thank you, Michael.
Absolutely.
Thanks, everyone. Thank you, Susie. Before I introduce these distinguished gentlemen, I'm just going to give you the usual few Zoom instructions. Beatrice is going to keep everybody muted because we're a large group, and that will ensure that there's better quality audio. Perfect. That was perfect. There's a couple of ways to view the Zoom call. Top right of your Zoom window, if you choose the gallery view, you'll see this beautiful mosaic of international faces. But when these gentlemen are presenting, I would urge you to use the speaker view, which brings them more prominently to your screen. I'm sure you've already been doing this, but there's an arrow center right of your Zoom window, which allows you to scroll through and see the many, many friends and colleagues who are on this call that will continue to grow. Bottom center of your Zoom window, you'll find the chat button. Once you click on that, it'll open a window to your right. That's where everyone is saying hello and putting where they are. Alas, right next to that is the share screen button. I believe Beatrice has disabled that function, but just be careful because sometimes people accidentally click on it. I also just want to let you know that we do record these calls. We share them on our video, on our website very, very quickly. And so you will have the opportunity to hear this again and share it with your friends, which is very good. We find lots of people listen to it. Okay, now it's my pleasure to formally introduce our guest this morning at the Wellness Masterclass. You know, there have been moments in history where circumstances created a need, a challenge, an opportunity. And that's when certain people step up and innovate and really lead. And this has really been one of those moments in the world. We're very fortunate that the three people here with us today answered the distress signal with science, technology, and a desire to impact our health ongoing. Dr. David Brenner, Fred Maxik, and Dr. Mike Roizen are here to tell us about their groundbreaking technology and to shed light, I'm sure you get a lot of those puns, on a safer, brighter future for us all. You know, reading their collective resumes would take all the time we have, so we will be sending their full bios in our follow-up email, along with information and links about the company and everything that we mentioned throughout this conversation. For white papers and scientific research studies and all of that, we'll send to you after. I'm just going to quickly introduce everybody. Dr. David Brenner is director at Columbia University Center for Radiological Research, which is the oldest and largest radiological research laboratory in the world. Dr. Brenner works with a multi-institute consortium developing technologies to rapidly test radiation exposure after large-scale radiological events. Dr. Brenner has published more than 270 peer-reviewed papers, written 2 books on radiation for lay people, has received numerous awards, and sits on several boards. Fred Maxik is the founder and chief technology officer of Healthē, with an E, not a Y, by Lighting Science, is one of the world's foremost experts in solid-state lighting. He has over 25 years of experience designing environmentally friendly technologies. He's the principal inventor on more than 175 patents in the United States and many more worldwide. And he's published several papers on light and its interaction with biological systems. His current project interests include biological lighting, off-grid lighting infrastructure, and expanding sensing capabilities of lighting solutions. Fred has been a part of the wider wellness world for a long time. He combines science and humanity and is a warm and wonderful human being whom I'm proud to say that I know. Dr. Mike Roizen has served as the first, as Susie mentioned, Chief Wellness Officer at the Cleveland Clinic. He's also the founding chair of the clinic's Wellness Institute and a professor at Case Western University. He's certified in internal medicine and anesthesiologist, renowned for the initiation and development of the real age concept to motivate behavior change. He served 16 years on FDA advisory committees, started 13 companies, co-invented an FDA-approved drug. These guys are no slouches. He's the author of 190 peer-reviewed scientific publications, 4 New York Times #1 best-selling books, and co-authors a daily column with Dr. Mehmet Oz that is syndicated in over 100 newspapers. And yet, he found time for us today, which is absolutely amazing. Mike's won lots of awards, and I'm proud, along with Susie, to say he's a member of the Global Wellness Institute Board of Directors. So these 3 incredible people have combined their expertise to give the world a game-changing innovation, and that's what we're going to talk about. The company is called Healthē, and we'll include a link in the follow-up email. I do just want to say that featuring these great scientific minds is not an infomercial for their company. We feel really strongly that health, wellness, and technology will drive the world forward, and it's important to share this information, give our GWS and GWI colleagues access to this information and to the people who are leading the industry, and really to educate the world on what's possible. Okay, gentlemen, I promised to ask you later about yesterday's incredible announcement. Let's start with this, though. When COVID-19 hit, did you immediately think, I know how to stop this? Did you have, dare I say, a light bulb moment? Can you tell us how this started? Fred, do you want to start? David, Mike, whomever.
I'll take a first stance here. I think we have known for some years that things like this were possible, and we've been talking to people about it for over a decade now. In various areas, we've worked with NASA over the past years and looking at how we can deal with pathogens in a very, very closed environment. So I think we had a very good knowledge base to draw from, and we had, from our side, already had products in the market that were capable of dealing with it. I think what COVID did is it really activated us to embrace how far we can take the science and how far we can push it to understand what it would do to potentially disrupt this pathogen from wreaking the havoc it has wreaked. And I think we are well within the bounds of this being able to deal with a good chunk of that. It is part of a solution, though. It's not a complete solution, but it is part of a way to make our environment, our built environment, a healthier and safer one for us to occupy.
It's incredible. Can you talk about the science a little? Yes, please, Mike.
Can I add? So when I read Dr. Brenner's science is what tipped this off for me. So I always carry a son with me, if you will, that smiles. But the point is that I always thought as a physician, we had located all of the TB sanitariums in the United States in the sunniest parts of the city. And you said, why? And we were told because the sun rays kill tuberculous bacilli. But in fact, what I learned when I started reading Dr. Brenner's work was that it is UVC, a specific component, not UVA or UVB, but UVC that is best for viruses and bacteria, and that most of the UVC is filtered out by the ozone layer. But a specific part, that is the UVC, you can generate in a lamp. A lot of Dr. Brenner's work was on that. And the amazing thing is how fast it killed viruses. So as you know, the Cleveland Clinic has a outpost for brain health, the largest actually in the world in Las Vegas. And all the shows were closed down. And I said, what if we could put a lamp on the back of every chair, because it doesn't show, if you will, visible light to any degree, but you could kill the viruses and have all the shows open. And so I got interested in saying, wouldn't this be a remarkable set of things? And couldn't you on airlines have, in fact, you know, those, if you will, those little lamps that go around you, the gooseneck, a small gooseneck in an airplane, because you'd kill the viruses that were coming in contact and the bacteria and stop a lot of the colds that occur on airplanes. And at the same time, I said, in addition, it cures the medical issue. We could have this in our emergency rooms. We could have this, if you will, between us and our patients, and stop the worry about medical professionals. And even since Dr. Brenner's work showed it wasn't dangerous for eyes or skin, the worries about the broad UVC wavelength, but having a specific one, that you could actually have this on in our ICUs and really decrease transmission. And so that's what got me really excited about this technology. And I hope I can then, if you will, pass it to Dr. Brenner to talk more about this.
Yes, please, absolutely.
Yeah, so I mean, my background here, well, even before me, it's been known for more than 100 years that UVC light is very, very good at killing bacteria and viruses both. And it's been used in many contexts over the last many decades. For example, in my own hospital's operating room, overnight, these lights, UVC lights, are turned on, and overnight they kill all the bacteria and viruses. And by the morning, you've got a nice clean room, which is great. But of course, what happens then? Well, people come into that operating room and bring their own bugs and pathogens into that room. So it's very good for cleaning any room. But what you'd really like is something that continuously cleans that room while people are there, because people are coughing and sneezing and producing their own pathogens. And the problem there is that we've also known for a long time that you can't directly expose people to conventional germicidal UVC light because that would be a health hazard, both to the eyes and to the skin. So really where we came into the story was to think, well, is there a type of UV light which we can use which would have the same killing properties, virus and bacteria both, as conventional germicidal UV light, but wouldn't have the safety issues. And would that be the case, then you could actually use it directly when people are around. And that's really what you want. You want to be able to decontaminate the air when people are around, not when people are not around. And what we came up with, was now 7 or 8 years ago, was a particular wavelength of UV light that we call Uvc light. Other people call it different things, but it's around 220 nanometers in wavelength. And conventional germicidal UV light is about 250. You might think that's a pretty trivial difference, 220 to 250, but actually it makes a world of difference. Because what happens at these lower wavelengths is that the UV light is actually absorbed in the outer layers of our skin, the dead layers of our skin. You know, on the surface of our skin, we have dead cells. The technical term is stratum corneum, but it's a few layers of dead cells. And this Uvc light, as opposed to conventional UV light, simply can't penetrate through this dead cell layer. So it can't reach the living cells in our skin. And it's the same story with the eye. Right on the very surface of the eye is a so-called tear layer. And this Uvc light gets absorbed in the tear layer. So again, it can't reach the critical parts of our eye, the top part being the cornea. So the idea here is this Uvc light is just as good as conventional UV light for killing bacteria and viruses. And as I said, we've known for a long time that it's very good at doing that. But it's safe. You can actually use it in rooms where people are actually hanging out and doing whatever they're doing without it being a safety issue. And that's the big difference between Uvc light and conventional germicidal UV light, that you can use it when people are around. And that's really what you want to do. So we were really interested in influenza, and we are actually approaching the flu season, as you know, and hope you'll all be getting your flu shots. But influenza is a major issue, and influenza is also transmitted primarily by airborne routes. And we were working on asking the question, can Uvc light kill influenza virus? So we'd been working on that for several years. Come the start of the COVID crisis, there was a light bulb moment where we saw pretty well immediately that what we were doing in the influenza world was absolutely applicable to the SARS-CoV-2 virus. Because, I mean, I think it was pretty clear to most people, maybe not some of the authorities at the time, that really this was an airborne transmitted problem. And I think we now know that's actually the case. So it was pretty easy for us to switch our attentions from influenza virus to SARS-CoV-2 virus. And pretty quickly, we were able to show that Uvc light is indeed very good at killing these coronaviruses. And that's really where it started from our perspective.
It's incredible. It feels like the best kept secret in the world that there is a way to do this with lighting. And I know, do products that do this exist anywhere on the market yet for consumers? I mean, how do you translate this science into the applications, into the world that, I mean, people are asking questions already about, you know, there's going to be a flood of people wanting these in their homes, their businesses, and everywhere else. How do you translate that? What do you do with this technology? How do you create these products? I mean, you're all so entrepreneurial. What's happening with that?
So I think, Nancy, we are continuing to introduce new products that utilize this technology. For instance, I just happen to have to say next to me.
Oh, great. Yes,
but
show us one.
So this is one that could be used in various settings. It could be used in hospitals, but it could also be used in homes or offices. It has both an optical light that could be circadian tuned or tuned to any other biological function we might be interested in, but also has an element on it that's a far UVC emitter, and that far UVC emitter can be turned on or off based on occupancy, based on time and various thresholds of exposure. And that's all programmed in a light that could simply be turned on and off with a light switch. So if you can imagine that it could fit in this form factor, it can be used fairly ubiquitous. That's the path that we're going down. There will be quite a few new products coming out, and there are a number that are already in the marketplace and shipping today. But offices, homes, recreation areas, all possible today already.
Well, I'm sure that, you know, a number of people that are on this call are in the spa and hospitality world. I mean, a lot of them are in the business world. All of this global. First of all, does it work everywhere in the world? And you know, the application, where are you currently? I know you've got some in health clubs, you've got some in residential buildings already. Can you talk a little bit about how this is going to get deployed?
Well, I think this is going to be seen in so many areas. I think the health, spa, any places where people tend to congregate, and potentially shopping malls, office buildings, or around the coffee pot to start with. I think we're going to look at some of those higher concentration areas first. Senior living, big users as we move forward. So I think as it becomes more and more available and more accessible, we'll see quite a few additional application spaces. I know Michael and I have talked about a number in the future, theaters and other things like that are well within our sights in the near future. But the technology is also going to evolve into ways that it becomes more applicable and more friendly in certain areas. We're looking today at sort of the first phase of what this is today, and that's dealing with the problems we have today. This may just be a practice for the next pandemic, and how we build this into our environment to make it more resilient to these pathogens occurring is going to be critical for how we move forward. And we'll devise and design new form factors to accomplish that.
How much of this, I'm sorry, David, you have to go ahead.
Yeah, if I might jump in there. And
sure.
What one sort of fundamental difference between this approach and an approach like a vaccine, for example, is this is one size fits all, that the far UVC light, or UVC light in general, kills all bacteria and viruses, whereas of course a vaccine is very, very specific. So what we're doing here is preparing us for upcoming influenza seasons, but it's also preparing us for the new pandemic, which will no doubt appear within our lifetimes. We'll be ready next time around, so we don't have to change anything as the pathogen or the virus changes. We'll be ready.
I also think, as David, you are fond of saying in other conversations we've had, unlike pharmaceuticals to treat these pathogens, using light as a countermeasure does not create the drug-resistant strains we're seeing where other pharmaceuticals have been applied in the past. So this gives us a much more direct approach in how we inactivate these viruses and pathogens, but also doesn't create the downside of what's happened with pharmaceuticals in the past.
Nancy, let me go and say, so the Miami Dolphins are using a number of these in their locker room, both with air filtration and with a light, so protecting the players from the pathogens from viruses. It can be used, obviously, as an entrance to a spa, if you will, with the Topher. So, Fred, if you would describe that in a few seconds. It can be, but the locker room use is the comparative to the spa. This is a perfect use for it, if you will. And as I think David mentioned, the great news is once you have this in, you don't have to worry about the next generation of viruses or mutations in the viruses, as this inactivates or kills the virus on. And I think David, you or Fred, one of you, it's a 99% kill rate over 15 minutes. So
that was a question, was how much time exposure and how much of the lighting is needed in a space, like, you know, what's the ratio of light to space to know that it's effective?
So David, do you want to start that, or you want me to?
Go ahead, Fred, you take it.
Yeah. So this is all ultimately about a calculation that we call fluence, and that is how much light over what period of time, over what distance has to be transposed to inactivate a given pathogen. All pathogens have slightly different dosings based on the size of their RNA or their DNA, or essentially what makes up the target area we're trying to hit. And there's good documentation on what pathogens require what levels of fluence to be inactivated. So it is all time, distance, and power dependent. And if we trigger any one of those three legs, we change the others. So I would say from David's research, which I'll let him speak to directly, this particular pathogen we're concerned about can be inactivated fairly quickly at fairly low power levels, and is very appropriate for this type of treatment. I don't know if, Dave, you want to speak about exactly what you found?
Well, maybe I'll speak a bit more generically. I mean, my picture of what happens in an indoor environment, I mean, when a few people are in a room together, is that we cough and we sneeze and we shout and we sing, and that produces viruses in the air. And they're all contained within droplets or aerosols. And there are various sizes of these aerosols and droplets that are produced. So the bigger ones actually drop to the ground within a few seconds very quickly, and within a few feet. And that's the reason why we have our 6 feet social distancing rule. But the smaller ones don't. The smaller ones start floating around in the air, and they can stay in the air, and the viruses inside those aerosols can stay living for hours, literally. So really what we want to do is be able to just reduce the ambient level of virus that's in the air in a group setting when people are around. So the question isn't really, how long does it take to inactivate a particular virus? The question is, what can we do to over a period of minutes and many minutes to reduce the level of ambient virus in the air? So that's what I see Failla UVC as being very good at doing, is continuously exposing the air in an occupied environment and continuously decreasing the level of virus in that room.
Has this been tested specifically on COVID-19?
Yes, it has. It's been, well, the first tests that we did were with different coronaviruses, which we were able to aerosolize and then show that Failla UVC light could kill them. But subsequently, actually several groups now have demonstrated that Failla UVC light is very efficient at killing the SARS-CoV-2 virus.
Are there any risks associated with exposure to this? I mean, obviously, historically, UV has had a bad reputation in terms of human interaction. Obviously, this is a whole new level and a whole new thing. But what is the research behind that, and are there any risks to that?
Well, you're right. The conventional germicidal UV light you can't use directly expose people to it because of the risk to the skin and the risk to the eye. So really, the fundamental thing about Failla UVC light is that it cannot penetrate into the living skin or into the living eye. So in terms of safety, I mean, there are several ways you can approach that question. So one is what I just said, the pure physics of the matter. A second one is that there are actually a whole bunch of regulations that have been in place for the last couple of decades for UV light and wavelength-specific regulations. And it's very important that we stay within those regulatory limits. So it is a regulated piece of equipment, and all the manufacturers, including Healthē, are going to stay within those regulatory limits. And then the third part of the story is that, in fact, lots of people, ourselves included, are doing research in terms of both of the efficacy, killing viruses, but also the safety. So there have been over the last 7 or 8 years now. There have been lots and lots of studies, nationally, internationally, on safety, both short-term studies where you exposed to high doses of UVC and then look pretty quickly to see if you see any effects. But also, for example, there's a long-term study that's going on at Columbia where we've been exposing hairless mice for just about a year now to actually quite high levels of Uvc light continuously, 8 hours a day, 5 days a week. And we examine those mice every couple of weeks, both for any skin issues or any eye issues. And now, just about 1 year into that study, absolutely nothing. We don't see any skin issues. We don't see any eye issues compared with the control mice that in the adjacent room that don't get any UV light exposure. So we've got three approaches. We've got the physics of the matter. We've got the regulatory framework, which we are definitely going to be going with. And we've got a lot of experimental studies now.
Does anybody else of the three of you want to add anything to that before we move on? Yep. Okay. So I can tell from the questions that people are already figuring out how to implement this technology and what they're doing. There's some questions about the impact of this light on textiles and all the surrounding and furniture and other products that are in let's say in a hotel room or in a spa or other things. So can you comment on what exists in terms of research on the any risks to surrounding environment for this?
So there have been over the past 20 plus years a number of papers of the effects of UVC light specifically on materials and on material properties. Certainly there are some elastomers that are at risk to a degree, but again, this is a function of that light being able to penetrate into those elastomers versus a surface phenomenology. So we would expect this to have something less than the effect of what you see with the 254 tests that have been published to date. But there might be some. I would look specifically at elastomers as being a potential area we should continue to investigate. But in other materials, we haven't seen anything. Now we've had these already in marketplace under a lot of different conditions for going on 6+ months in the far UVC parts. But on the UV parts, we've had them in there for decades. We've done studies with NASA that go back 10, 15 years ago about what happens when we put these in. So I think those answers are fairly well known, and there's a couple of materials we probably want to stay away from. But for the most part, it's reasonably solid, reasonably safe, and has very small effects.
And I might add, from my perspective, I mean, if you are balancing the opportunity to prevent the transmission of COVID-19 versus the potential for maybe some fading in some materials, well, I know where I would go.
So a question has come up from Don Genders, and that is with a single lamp, an example of like what size room would a single lamp serve? And there are questions also, I know Austin has raised one from Garini, the idea of voltage and different currencies and stuff in different parts of the world, and how does that impact?
Let me speak to the second question first.
Okay.
And that is the power supplies that go into the units physically are multi-volt power supplies. They can be used anywhere in the world, anything from 90 volts to 277 volts or even higher if need be. So there's no limitation that power is converted and transformed inside the unit to be a power that's useful to the unit itself. So the location in the world this exists should have no bearing on how it operates. So that's the easier question. The second question is it depends on the characterization of the room and the level of fluence that's required in the room, but also along the thresholds that are set by various regulatory organizations. So based on what we're allowed to put in that space, these meet currently the North American thresholds. We believe it also the European thresholds are the same. Today, we can characterize a room based on the environment, based on the ceiling height, based on the hanging height of the fixture, and we can come up with a calculation to give that answer. But anything typically from 100 square feet up is typically what we're seeing.
Okay, interesting.
Fred, do you want to comment
We'll take a dozen.
So let me just ask Fred, in the Miami Dolphin locker room, which is a locker room situation, how many units did you put in for what square footage? Because that would be the highest use, the highest number of, if you will, or the most lamps per a unit, if you will.
Well, so the Miami Dolphins locker room is actually 2 units. It's our new 2x2 troffer, as well as the downlights that are going in. So it's roughly 1 per every 100 square feet.
Okay, so there are a couple of questions in terms of regulations. Paul Groves asked one, Sammy Garini does. Is this regulated by the FDA or any other kinds of standards? And Andreas Blum asks, does it also kill the good bacteria?
Yeah, I could perhaps take that one. Absolutely, it's regulated. Not by the FDA, because the FDA essentially regulates things which are there to actually cure people. So if we were using this light as a curative modality, then the FDA would be involved. But it's a preventative approach. So there are regulations, and the regulations are from a quasi-government organization called ICGIH, but there are also international regulations too. And that basically tells you what level of UV light at any particular wavelength the general public or workers can be exposed to per day or per hour. And as Fred said, it's pretty important that we stay, and we will be staying within those regulatory limits.
So Martin Goldman is asking a question that I've been wondering, and is, why has this not been discussed publicly before? Why don't we know about this? I mean, I would say, I know I'm certainly not a scientist, and I don't, go looking at all kinds of lighting, but something this game-changing, you think would have been brought to the fore prior to this moment in time. Can you talk a little bit about that, sort of historically? And you're smiling because you've probably been banging on this door forever. It's like the overnight sensation that's 25 years in the making, right, Fred?
It is, and credit to David as well, who has done a couple of TED Talks on this over the years already, and so it has been discussed in public. Unfortunately, the audience listening was quite narrow in the earlier days, but this has been around for a decade plus. It has been worked on for longer than that. I was exposed to it 13, 14 years ago when it was installed on a piece of equipment over at NASA. So it's been there, it's been discussed, but the ability of folks, or the sort of the thoughts of folks to listen to it was not quite as imperative as it has become today. And as anything, it is now being pushed into that foreground. But again, David has done amazing work advocating for it and studying it, and we need some more people to start listening.
Nancy, I'm going to comment. So this was so poorly known that David had to do a GoFundMe campaign for some of his research looking at this virus, actually, with it. And the reason in medicine we use broad UV at night in our operating rooms and in our regular hospital rooms to cleanse them and clean them. But it's always been thought this is too dangerous for eye and skin to be used regularly. And so David's really groundbreaking research showing that this set of wavelength, 205 to 222, was in fact safe for humans and was safe for mice too, has really been enormously important. And so it is an overnight sensation, if you will, but so David's had to probably turn away other things than Fox News and Good Morning America recently to have some time to himself.
And one of the issues is that over the past few years when we worked on it, there really hadn't been a large-scale source of these lamps. And really, it's only since the beginning of COVID-19 that various manufacturers, Healthē certainly being one of the major ones, has really stepped up to the plate in terms of production. So had you asked 3 years ago, can you install this in the Miami Dolphins locker room? The answer would have been no, because the lamps really didn't exist in large numbers. And we could buy lamps in very small numbers, ones and twos and threes to do research. But in terms of the large numbers that obviously we'd like to use, they didn't exist at that point.
A question has come up a couple of times, and David Chan has asked it as well, and that is dry hydrogen peroxide. What, as a disinfectant, how does it compare to this?
Well, it's different. I mean, I would compare hydrogen peroxide to having the UV lamps on overnight when people aren't around. So what the really big thing about Failla Uvc Light is it can be used in an occupied room when people are around, and obviously you can't use hydrogen peroxide in the middle of an office meeting, and it's also not useful for disinfecting the air, which we believe now to be the principal modality for transmitting COVID-19 through the air. So hydrogen peroxide is great for cleaning surfaces, but is that the important transmission mode? Probably not.
And I would add to what David just said, in that we really do have this instance of this particular virus that when we're in a space and we're occupying that space, we don't want to have to evacuate it to clean it. We want to be able to reutilize that space in real time, whether that's a dressing room of a retail shop, whether that's a conference room in an office building. The fact that this is cleaning both air and has some surface cleaning as well, effects to it, that gives us the ability to dynamically utilize a space and to be continually reducing that viral and pathogen load in that space as we're inhabiting it. I think that's a strong differentiation between this and pretty much any of the technologies that are being discussed.
Are there technologies in addition to the FAR lighting that you're doing that work in concert with the lighting, air filtration, other things that you're doing that kind of combine to really take on viruses like COVID and others?
Certainly. I mean, everything that could help reduce that load is very important, and we make products, and there are products out there that have things like HEPA filters in them and other types of filters in them, materials we add to the rooms like TiO2 or other things to help activate surface cleaning where that's required. But this pathogen in particular is an air-based one in terms of how it is being communicated between us, and the ability to clean that in real time and deal with air that's not going to be drawn through an HVAC filter, but in real time and in real space, is a strong differentiator. But HEPA filters and other things make it even a more powerful application.
But Fred, you've also got a system where the air is filtered with a HEPA filter and the UVC on it. So just, Nancy, so it's a really good question, meaning how do you make sure the air gets filtered and you bring a strong, if you will, air filter with the UVC built into it in addition to the HEPA, and you kill the viruses and bacteria in there.
Yeah, and you also deal with some of the particulate matter that just projecting light into a space would not necessarily deal with.
I would remind you of two of our more standard approaches, and that's using masks and using social distancing. So Failla Uvc Light is in no way replacing those. I certainly see it as just another weapon in our battle against this terrible disease, but absolutely the standard approaches we need to keep doing.
Dr. Brenner, is there research in the pipeline, Melissa wants to know, about the impact of this lighting, big studies and stuff being conducted?
Yes, absolutely. I mean, there are a lot underway, and I talked about just one big study that's ongoing at Columbia where we're radiating or exposing hairless mice to Failla Uvc light over a very long period of time. But there are many other studies going on in Europe and in Japan also. For example, looking at the effects directly on human skin. And those studies that have been published so far have been very encouraging. But yeah, I mean, one of the things about safety is you can never prove that something is safe. You can prove something is unsafe. So the way safety works is you basically have to approach the problem from various sides, from the regulatory side, from the basic science side, and from the experimental side. And those will continue.
Kim Sturzer wants to know if you've all got this lighting installed in your offices.
I will just tilt the screen, and that's it behind me.
Okay.
So yes.
And can you talk a little bit about the cost, and then I'm going to let you talk about the big announcement from yesterday. But can you talk a little bit about the cost of this?
The cost is not prohibitive. If you're installing it in sort of the critical areas, it is very in pretty much any commercial setting. It differs based on things like ceiling height, based on pendants, but it is not, the cost should not be what's prohibitive. One of the things we've tried to do, and I'll get a commercial for a second, is we've tried to make it an approachable technology when trying to build it to scale as quickly as we can to drive those costs down. So I don't think costs would prohibit anybody from entering into this type of application.
Sandy Abrams, who will be at the summit in Palm Beach, is asking whether we're going to showcase this at the summit in Palm Beach. And I will just, sneakily let this inside group know that we've sent Fred to the breakers to see whether it's possible to have some of this lighting at the summit, which would be incredible, not just to showcase the technology, but to add to the many, many ways and protocols that we're using to keep us all healthy and safe at the breakers. Okay, yesterday there was a very big announcement, and which one of you would like to talk about it? And I know Craig Kogut from Pegasus Capital Advisors is also on the call. He's gone dark up there. Craig, are you still with us? You've turned off your video, but this was and you're muted, but this was an incredible announcement. Craig is involved with the company as well. Which of you would like to tell us about the announcement?
Well, thank you for that, Nancy. I went dark because I had cats wandering in front of the screen.
We love that. But
it might be distracting. But for Fred really worked hard on this together with the whole Healthē team. It's a great accomplishment to, our Abe Morris, who's on the call, I think. I don't know if Wes Naylor is, but it was a team effort. Fred, you want to talk about it?
Yeah, I certainly can. So yeah, we're very excited. We've been working with the Boeing folks for a while now as a team. We have about 5 or 6 of us who have been working fairly constantly on it over the last several months. And the announcement is that we will be making a far UVC wand for them to utilize in the cockpits and the cabins of their aircraft and of their aircraft customers.
This is Boeing. I think I'm not sure everybody heard that. Yep.
Which are the major airlines around the world, and they've already seen a very, very positive response as part of their initiative to bring the airline industry and the travel industry back to what the new normal will be. And we have a very, very effective unit that we've developed with them that is going to be out before the end of this year.
Fred, this is Wes. I am up, by the way.
Hey, Wes.
Good to hear the conversation.
And Wes has put fabulous efforts into making this happen, and greatly appreciated. And without him, this would not have happened. So we're very excited to move this forward.
Will that wand be available to consumers as well?
It's not really a consumer piece. It's more of a commercial piece. It's a very, very high power, very fast acting piece. But we will see that in other commercial spaces, certainly. And what we might derive from that going forward, we'll still in discussion phases.
And I just might add, as someone who's been in the hospitality business, and again, high touch, rapid cleaning needs, I see this becoming a very viable product. I mean, it wouldn't be to clean every room, but particularly in widely used spaces, I think this product will have tremendous applicability. Fred, you agree, I assume, with that?
Yes. Yeah.
And Craig and Fred, and actually one of the other areas I think it's exceptionally applicable, and certainly Department of Defense and other people, high-tech companies should be looking at this, because it provides a cleaning and sterilization capability in electronic intensive environments that do not lend themselves to chemical decontamination due to the sensitivity of the electronics. So that kind of moves it into another very specific space that it can take on that role.
Are there consumer products, consumer versions of something like that, either in the works or available?
We have something in the works that we've been looking at for a while. There are quite a few wands that are out on the market today, and I say that a little dismayed. I've tested some dozens of them, and not one has worked yet. So I'd be very cautious of what people do in that space. It does, as David has pointed out, require a very specific amount of fluence to inactivate this particular pathogen and others. And most of those products out in the market, and all of them I've tested to date, do not meet that criteria.
Okay, that's not.
And to be clear, Nancy, none of those products are far UV that are being sold to consumers that we know of. They're regular UV. Some of them have, I think, safety issues too. But as Fred's saying, they may have no impact anyway. So you're endangering yourself for nothing.
How are you going to educate people?
I would add too. We've also tested a number of products that claim to be far UVC that are advertised on the internet, and by and large they're not.
How are you going to educate people about this? I mean, you have in front of you today hundreds of very educated people in the wellness and well-being field, and I think this is of great interest and news to a lot of us. How will you educate people about the value of this and the importance of this? Any thoughts? Any plans?
We are spending a great deal of effort and time around how we create that messaging. We've brought on a wonderful science board to help us get that out. We've entered marketing to get that out, but we're also in partnerships with folks like Boeing. We're going to get that word out. But this is not your grandfather's UVC. I grew up being taught stay away from UV.
Yes.
Lather yourself in sunscreen.
Exactly.
This is a whole different wavelength, and that, as Dave pointed out, that difference of only 23, 24 nanometers makes a world of difference on how our biological cells interact with it. And in fact, it does not penetrate us. It is not the same as we have seen with UVC before. So we have to get that differentiated message out.
There's one thing I just want to mention, because I'm watching the clock and lots of questions are coming up. And I mentioned this earlier, but I will again, that we saved the chat with all of your questions, and we are going to get that to David, Mike, and Fred, and let them answer a lot of those questions. And then we will send that in the follow-up email so that you have answers to your questions. We can't in this time get to all of them. And we do keep everything on time and on schedule. So appreciate your patience with that. This is extraordinary technology. I do hope you will indeed come to the summit and tell everybody about it. So two questions. Where do we buy it, and how do we invest in the company?
I think you could start at Healthē with an E, inc.com, and we can make contact there. You will have a list of our emails at the end of this call, and we can make sure that any interest gets transmitted to the right folks internal to the organization. On the investment, I think I'll leave that to Craig if he's still on.
Well, I am still on, and I would say right now it's a subsidiary of another company. We're effectively at Pegasus the largest investor. Hopefully there will be an opportunity to invest in the future. But as of now, we are well capitalized, and we just want to help with getting this out to the market. But stay tuned.
As do we. And we will make sure that all the links to the company and everything else and people's emails are in the follow-up. Susie, do you have a question before we finish?
I did have one question back to the cost question. Fred, what you showed us, how much is that? Because it's hard to, the locker room and the size and 100 by 100, I'm not sure what that all is, but, that particular mechanism that you showed us, how much would that cost?
You're muted. Yep.
You're muted.
So again, depending on volumes and things like that, you're in around the $1,000 to $1,200 range on something like this. So if you're putting into a building, you're in around the range of about $10 a square foot.
Okay, fantastic. All right, there's a question that I ask everybody.
I'd say, and Fred, you were commenting that you're trying to mass produce and bring the cost down. So if that is unaffordable for people and widespread, you will be bringing the cost down as you manufacture up.
Absolutely, and to be clear, we are already mass producing it. We are capable of making thousands at a time today. We will be moving that up to making 10,000 at a time in the very near future. So they are available, and we intend to drive the cost of it down as production volumes ramp up.
Fantastic, and I can see Craig smiling for those thousands of for the mass production, which is incredible. So there's a question I ask every masterclass participant, and that is, what keeps you up at night and what makes you optimistic about the world? And I'm going to ask each three of you to answer those questions very briefly so we can meet our time. Mike Roizen, do you want to go first? What keeps you up at night and what are you optimistic about?
What keeps me up at night in general, not related to this, is that we don't have long-lasting immunity from some of these viruses. So with the coronaviruses that cause colds, we get them every 2 to 3 months, or can get them every 2 to 3 months, which means we don't have long-lasting immunity against the general coronavirus. So that's what keeps me up at night. And what makes me optimistic is we have got literally 130 new vaccine platforms to help us with that. And people like David and Fred are working hard at getting this technology to be much more available. So if you will, and I'll give Craig a tip of the hat for helping to make it more available too. So those are the optimistic things, is you got a lot of bright minds working on this area.
Thank you so much, Mike. Fred?
What keeps me up at night, I guess, is the same thing that kept me up at night as a 9-year-old child. I used to take a flashlight and shine it through my hand and look at it under my covers. And it just fascinates me that this is something that actually penetrates us, and it penetrates our environment, and collectively we've lost that. And what I'm optimistic about is I think we're regaining it. I think we're beginning to see that this ubiquitous light that we have is impactful on our biology, our physiology, our environment. And I think that will provide us a number of solutions to a number of ailments as we go forward.
Fred, thank you so much. And Dr. Brenner, you have the last word.
Well, what keeps me up at night is the same thing that's keeping the other 251 participants on this Zoom up at night, and that's COVID-19. And where I'm optimistic is we now have just one more tool in the battle against the transmission of COVID-19, and really we have so few tools. We have masks and we have social distancing, but we really don't have much else. And I see this as a third tool in the big fight.
Well, I want to thank you all. This is game changing. It's an incredible innovation, and we thank you so much. Craig, thank you as well. We cannot unmute everybody, but you can unmute yourselves and just give a round of applause to these incredible people doing this groundbreaking work, and we so appreciate you sharing it with us.
Thank you.
Thank you, Fred. Thank you, David. Thank you, Michael.
Way to go, Wes.
Okay, Wes. Tremendous amount of interest in it. No, it's not surprising. So we'll send all of that along.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you, Susie.
Bye now.
Just incredible.
Thanks, Mary.
Good night.
Thank you.
Don. Bye, Nancy.
Bye. Thank
Bye.
you. Ciao, ciao from Madrid to Spain.
Bye.
Ciao.
Thank you.
Fred,
God
we'll talk
bless
about
you
the breakers.
Grazie mille.